Hello everybody, welcome back to another video, and in this video we're going to be taking a look at a question from the IB Chemistry Paper 2HL from May 2018 Time Zone 2. Now, as I mentioned in my previous video, I put out a post on my Instagram where I asked you guys which questions you find or which topics you find difficult, and an overwhelming amount of people commented topic 1. So here I am doing another question from topic 1, and over the next 2-3 days, I'm going to be posting videos on only topic 1 questions, and hopefully that covers just about everything you need to know for topic 1 and how to tackle the questions that come in the exams. And I'm picking out questions directly from exam papers here, so you know what kind of questions they ask and you know what all you need to know for the questions they ask. So let's get on with it. A student determined the percentage of the active ingredient, which is magnesium hydroxide, MgOH2, in a 1.24 gram antacid tablet. The antacid tablet was added to 50 centimeters cube of 0.100 mole DM of sulfuric acid, which was in excess. Now, this part over here, which was in excess, basically means that you had more sulfuric acid than you had the antacid tablet. So that's all they are telling you over here. They're asking us in the first part, calculate the amount in moles of the sulfuric acid. Now, extremely simple. How do you do this? This is the formula. So number of moles, which is N, is equal to concentration times volume in dm cubed. Now, volume should be in dm cubed, okay? So we already know what the concentration is in the question. The concentration is 0.1. And we have to multiply this by the volume in dm cubed. Now, they've given us the volume in centimeters cubed. Be very careful of this. They've given it to you in centimeters cubed, but you can't use this. You have to first convert it to dm cubed. So how do you convert centimeters to dm? Well, you just divide centimeters cubed by 1,000. So we have 50 centimeters cubed. We divide this by 1,000 in order to get the answer in dm cubed. And if you just put this into your calculator, because this is a paper 2 question, so you're allowed to use your calculator, you would get your answer as 5 times 10 to the negative 3 moles. That's it. That is it. That is all that you have to do for this question. That is your answer. Boom. There you go. 1 mark secured. Let's move on to the next part. Formulate the equation for the reaction of H2SO4 with magnesium hydroxide. Now, this is a question that I've seen come up a lot in exams. So they ask you to formulate equations for certain reactions. Now, if you have reached the part of acids and bases in your IB syllabus, you would know that when an acid reacts with a base, the reaction is known as a neutralization reaction. And that is because the base, you can think of bases as negative charges and you can think of acids as positive charges. And when these two react with each other, they cancel out each other and then neutralize each other. You can think of it like that. I'm just giving you an analogy so that you can conceptualize what I'm talking about. So when an acid reacts with a base, it's called a neutralization reaction. So acid, in words, when you react acid plus base, the products that you get a salt and you get water. Now, we already know 3 of these things. We know the acid, which is H2SO4. We know the base, which is MgOH2 or magnesium hydroxide. We know what water is. Water is just H2O. All we need to do is figure out what the salt is. And let me tell you a quick tip, which will help you find the salt very easily. The salt which is formed by the reaction of an acid with the base, the salt is made up of 2 things. It is made up of the negative part of the acid and it is made up of the positive part of the base. So if you look at the acid and the base is made up of 2 parts, the OH, which is OH minus, and the Mg, which is Mg2 plus. And therefore there are 2 OHs, so it balances out the charge. As for H2SO4, it is also made up of a negative and a positive part. It's made up of SO4 2 minus, and it's made up of H plus. And there are 2 of H plus, so it balances out the charges. Now, the salt is made up of the positive part of the base and the negative part of the acid. This is always the case when you react an acid with a base. So the salt is actually MgSO4, the negative part of the acid and the positive part of the base. That is how you make the salt. Hopefully that is clear to you. Oops, that is a very simple trick. For a long time, I struggled to formulate equations because I used to always be like, okay, what the hell is the product going to be? But my tutor taught me this technique, and ever since then, it's been an absolute blessing, and I've been able to figure out such questions. Now, the second step that we need to do, now we've got the equation, now we need to make sure that it's balanced. Let's see if it's balanced. How many hydrogens do we have on this side? We have 4 hydrogens, 2 over here. And oops, I made a terrible mistake. This 2 is meant to be outside the bracket, not inside. Sorry, my sincere apologies. We have 4 hydrogens, 2 over here, and it's OH2, so there are 2 hydrogens over here as well. How many oxygens do we have? We have 6 oxygens because we have 4 over here and we have an additional 2 over here. How many magnesiums do we have? We have just 1 magnesium. And how many sulfurs do we have? We have just 1 sulfur. Let's take a look at the right-hand side. How many magnesiums? We have 1 magnesium. Okay, that's good. How many sulfurs? We have only 1 sulfur. That's good. What about oxygen? Ooh, we have 5 oxygens. We are lacking 1. How many hydrogens do we have? Ooh, we have only 2 hydrogens. So we need 2 more hydrogens and 1 more oxygen. And the best way to do that is to just put a 2 over here, because now we have 4 hydrogens, and now we've given 1 additional oxygen. So we have 6 oxygens. That's it. This is the balanced equation. Remember, if you want to get your marks, the equation must be balanced. It should not remain unbalanced. You will not get the marks for that. So this is the correct equation. And last but not least, we have to also write the symbols, the state symbols at the bottom. So we know that the sulfuric acid is a solution. So if you put aqueous, we know that the antacid tablet is obviously a solid. And at the end, we dissolve the antacid tablet into the sulfuric acid, so it also becomes a part of the solution. So our salt is aqueous, and obviously water is just going to be a liquid. So that is our equation. Hopefully I have made it clear enough for you. Hopefully you understand the concept now. I have to figure out, oh, I've carried over some parts and it's missing. I'm just going to rewrite it over here. Just bear with me for a second. If this is unclear for you, you can just rewind the video and see my more clear equation, which I wrote below. Anyways, let's move on to the next part of the question. Here, it's part C. They've told us the excess sulfuric acid required 20.80 centimeters cube of 0.113 mole dm of NaOH for neutralization. So remember, at the start of the question, they told us that the sulfuric acid was in excess. So that would basically mean that once we have completely dissolved or neutralized all of the magnesium hydroxide, we would still have some additional sulfuric acid left over. And this additional sulfuric acid that was left over was neutralized by NaOH. And they've said that we needed 20.80 centimeters cubed of 0.113 mole dm cubed of NaOH to neutralize the sulfuric acid that was left over from the earlier reaction with magnesium hydroxide. Now they've asked us to calculate the amount of excess acid present. And by amount over here, they mean moles. Just to clarify that, they mean moles. I know it's quite weird that the IB hasn't specified it, but what they mean is they mean moles. Now, before we approach this question, you may be tempted to just find out the number of moles of NaOH and then automatically assume that that is also the amount of excess acid present, but that would be wrong because remember, you have to first formulate a reaction equation for sulfuric acid with NaOH, and then we have to look at the molar ratios, and that tells us the relationship between the number of moles of the products and the reactants, or the products and the products, or the reactants and the reactants. And let's do that first. And you will see why you would be wrong if you just simply calculated the number of moles of NaOH and also assume that that was a number of moles of excess sulfuric acid. Let me show you why. Now, we have to write down the equation for the reaction of H2SO4, which is sulfuric acid, with NaOH, sodium hydroxide. And it's the exact same. It's a neutralization reaction again. So like I said, we get one product, which is water, and we get the salt. Now, the salt, as I said earlier, is made up of the positive part of the base and the negative part of the acid. Now, we have Na plus and OH minus, and we have H plus, oops, sorry, we have H plus and SO4 2 minus. Now, as you can see, if we want to balance the charges in the salt, which is going to be made up of this and this, we are going to need two sodiums. So the salt is actually going to be Na2SO4. And as you can probably tell, this equation is not balanced, and that's what we have to do at the very first step. I know that they've not asked us to give the equation over here, but in order to calculate the amount of excess acid present, formulating the equation is an absolute necessity. And now we need to balance this equation if we want to make sure that we get our ratios correct. So let's balance it out. How many hydrogens do we have on this side? We have 3 hydrogens. What about sulfurs? We have 1 sulfur, we have 1 sodium, and we have 5 oxygens. Now, what about the products side? We have 2 sodiums, we have 1 sulfur, we have 5 oxygens, and we have 2 hydrogens. So we need to increase 1 hydrogen, and we need to increase 1 hydrogen on the product side, and we need to decrease, or sorry, we need to increase 1 sodium on the reactant side. So the only way that we can increase 1 sodium is to put a 2 over here. So now this sodium becomes 2. And this 2 also means that the hydrogen also increases by 1. It becomes 4 hydrogens. And oxygen also increases by 1. So it becomes 6 oxygens. Now we need to balance this on the other side. And the easiest way to balance it is to just put a 2 over here. And that would make the number of hydrogens as 4 and the number of oxygens as 6. So now it's all balanced. Everything is good. Everyone is happy. So now we can figure out the amount of excess acid present based on the molar ratios as well. And as you can probably tell, look at the ratio that sulfuric acid is with NaOH. It's not a 1-to-1 ratio. And that would mean that if you had simply gone ahead and calculated the number of moles of NaOH required for neutralization and put that as the answer for the amount of excess acid present, you would be wrong, because the ratio over here is 1:2. So that means for every 1 mole of sulfuric acid, you need 2 moles of NaOH. So when we calculate the number of moles of NaOH, which, by the way, the answer for this, I've done it in a calculator. It's the exact same formula. It's just C times V, like I showed you earlier. You get the answer as 2.35664 times 10 to the negative 3 moles of NaOH. This is the number of moles of NaOH. And as you can see, the ratio is 1:2. So we need to halve this value. We need to divide it by 2 in order to get the amount of excess sulfuric acid. And the answer to that is 1.1783 times 10 to the negative 3 moles of sulfuric acid. So this is the number of moles of sulfuric acid that is required, or that was in excess. So that is the answer. Hopefully, I have made my point clear and what I mean by formulating the equation and getting the molar ratios. I really hope you understand that, because it's a very important concept. Now, the last part of this question, it asks us, calculate the amount of H2SO4 that reacted with MgOH2. So this is the substance that reacted earlier. How much acid reacted with MgOH2? And again, they're asking us amount. And by amount, like I said, they mean moles. And this is very simple. You just have to calculate how much reacted with MgOH, and we know how much is left over at the end. We know how much we began with. We began with 5 times 10 to the negative 3 moles of H2SO4, if you can recall. Let me show you what I mean. This is what we calculated up here. And I'm sure all of you know what we have to do by now. It's just very simple math. Just have to subtract this on this answer. Sorry, we have to subtract this answer from this. And our answer final is 3.82 times 10 to the negative 3 moles of H2SO4 reacted with MgOH2. That is it for this video. Thank you so much for watching. I hope I have helped you all a bit more in understanding this concept of moles and what all of this is about. I really hope that I have made your life a bit easier in this subject. Thank you so much for watching. I'll see you in another video with another question. Take care of yourselves and wish me luck. I have my results coming out in 2 days and hopefully I do well in them. I'll keep you guys posted about what I get and what I don't. But anyways, thanks a lot for the support. See you soon.